And we are live. Episode 5 of Messari's Build Series. Ready to go today. Thank you, everyone, for joining us. And thank you to Adam and Diran, who are joining me and going to have another in-depth discussion on what it's like to build in crypto. And in particular, we're going to talk about high throughput data systems today, namely pricing data, given the challenges of aggregating information from dozens of exchanges, thousands of illiquid pairs, some of which are manipulated by spoof trading volumes and really unreliable data APIs from fringe exchanges. And then we're also obviously conquering and dealing with the issues that automated order books and on-chain decentralized exchanges present in terms of how you aggregate market data metrics for Web3 assets. So before we dive in, as a reminder, we've got Diran on, our head of engineering, and then Adam, who is the tech lead on our market data service, which we're going to talk about today at length. Diran, welcome back. Adam, why don't we kick off with you? Welcome to the show here, and why don't we start out as we have with the other folks on our team? Just talk a little bit about your background and journey to Messari, because you've been working on some of these gnarly data problems for quite a while, just in a different context.
Yeah, totally. Well, thanks for having me. Again, my name is Adam Inoue. I'm a software engineer here at Messari. Yeah. I started with an internship at Apple and did something totally unrelated to what I do now. And then after college, I was just 100% finance and accounting systems, like automating accounts receivable. Then I was briefly at Warby Parker automating their entire accounting, which was in SQL tables, which is pretty cool. Pretty tech-first type of accounting system. And yeah, now I'm here. So it's been a similar world for a long time, but this is the first full-time experience dealing with crypto data, which does present unique challenges that we're going to get into. So that's just a very, very brief overview. But I've been kind of a one-trick pony in that regard, 100% backend, 100% finance and accounting data. So.
And what was it that got you excited about the switch to crypto full-time? Was it like a red pill moment for you? Has this been lingering for a while? What's it's one thing to work on some pretty hairy back-end challenges, but what was it about crypto data in particular that caught your eye?
Yeah, it was brewing for a long time. I've told the story a couple of times, but long story short, my group of friends in college, I was pretty distant from the rest of them. I went to a different university, but the rest of them stayed together. And then one day, like we have a shared Slack that my friends have always maintained. One day a channel appears in it called Ethereum Collective. And I'd never heard of Ethereum before. I'd only heard of Bitcoin at this point. This was like 2016 or 17. And they didn't explain what it was in the channel. I think this was just like a continuance of in-person conversation they had that I wasn't in. But then like over time, the pieces kind of came together over the course of the next 3 or 4 years. And I just got really fascinated in like the philosophy of decentralization. So that's sort of how it happened. But I just got really excited about the opportunity, and I had such a good interview experience here. I've really dedicated myself to Messari at this point.
I think a lot of people don't recognize how maybe they do, maybe they don't, but I think a lot of people don't recognize how complex getting reliable market data is for crypto, just because there's an absence of standards. And so every data service is basically creating their own benchmarks and standards on the fly. And if you pull a dozen of the top data services and aggregators, you're going to get a dozen different results on things like volumes, market cap sometimes, but like just on the pricing side, the VWAP, volume weighted average price, and the volumes themselves are going to be slightly different according to what the methodology is that a given vendor is using. That's the sort of thing that doesn't happen in the traditional markets. One, because there's kind of years and years of standards that have accrued, and two, because volumes are concentrated usually on the exchanges in which like a given equity is listed. No such thing exists in crypto because these are totally portable assets, right? So I guess why don't we just start by talking about the challenges of like, what are the variety of sources? I kind of hinted at them in the intro, but like, what are the different sources that you're grappling with? And then we can use that as like the starting point and start to branch into all the different challenges that emerge from that, and kind of how we build a scalable system that doesn't just incorporate everything that's already happened, but is kind of forward compatible, as we know that there are going to be changes in the rankings in terms of like the dominant exchanges. Each asset pair is going to be slightly different. And then there's going to be additional things that we have to grapple with in the future, such as, futures and margin and all sorts of derivatives that, might ultimately tie back to the spot price.
Yeah, totally. Yeah, we're spot price only right now. Even getting to that point with the amount of, as you said, I couldn't have said it better myself, like the amount of or the total lack of standards involved in ingesting that data. Right now, we have one major provider that provides the vast majority of our centralized exchange data, which just by virtue of the way order books work versus DEXs and with gas fees and everything, comprises like almost all trades that happen by volume. And that partner is Kaiko. We use them to ingest the vast majority of data from all large exchanges that everyone uses centrally, like Coinbase, Binance, etc. And then like on the fringes, we have a very large number. I think we're up to 22. That's probably wrong, but near there, a couple dozen bespoke integrations, mostly using the graph that we will use to grab DEX data as well. So right now we have a lot of capture. We're trying to get as much volume as we can. And we know that there are still dozens more integrations to build in order to get anywhere close to capturing everything. So yeah, it's a very large process. And each integration requires some research into how the protocol works or the network that it's on works and how reliable we can get a data feed. It's nice that we have like companies that have specialized in providing relatively standardized WebSockets. Kaiko is a great example. Because otherwise the work to integrate with each of these in a reliable manner would just be totally unrealistic, right, for us to do without a very gigantic team.
Let's dive deep into what is a price. So I think a lot of folks might be surprised by this concept that price isn't just a single thing, and it's also not being agreed across the crypto industry. Just because there's just so many sources of trades that are out there. There's centralized exchanges, there's derivatives, there's decentralized exchanges. Let's break it down for people. In a centralized exchange, and let's just take one centralized exchange as an example. How is the price determined? Through what for some folks, it might be super familiar. Some folks, it might be a nascent concept, the concept of order book. How does that determine?
Okay. Yeah, so yeah, as Ryan said, the price is usually just the nexus or the agreeable price between whatever the buyers and sellers of a market are. So the way order book markets work, the vast majority of all markets that have historically existed, is that you have someone who wishes to sell this amount of volume at this price, and someone else who wishes to buy this amount of volume at this price. And those orders are placed in an order book, and they just sit until someone comes along who is willing to accept that order, right? So that's where you have this concept of makers and takers, right? A maker is someone who places an order into an order book. A taker is someone who is accepting of the terms of that order and decides like, okay, I'll take that. And the vast majority of the time, these things happen in a matter of seconds, right? Like if a Bitcoin is currently trading for like 40 or 50K, let's say, then there will be a huge amount of people willing to buy and sell at a price very, very close to the currently agreed market price, right? And it's only in like extremely volatile market situations, which crypto has more of than the stock market does, where you might see like, okay, there's 200 Bitcoins available for a particularly low price or a particularly high price if the market is unstable. And it takes a while for those trades to get executed, but just depending on people's willingness to make and take orders, you'll see the price move slowly in whatever direction. So there's a lot of benefits to that system. Obviously, it's centralized, so it have a crypto first ethos even when it occurs in crypto world, but it avoids a lot of problems for what a price is. Like a price becomes simply like the reflection of recent trades that have occurred in the world. And when you have one place where an asset trades and no more, then you don't have to worry about any of the more complex techniques that we're going to get into For instance, like a company's stock will almost always trade in just one place, right? Like the NASDAQ, for instance. And just to look at the price, you just have to see the most recent orders that have been executed. But what do you do in crypto world where there's like 35 places where the same asset can be traded at different volumes in different ways? Like we have order books, and we have, decentralized exchanges that are completely different, and try to automate that market maker process.
Yeah, absolutely. So when there's a stark difference between a central exchange that is the sole entity where everyone trades all of the stocks, like you mentioned on Nasdaq, and there's a pretty big difference between the 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 polygamy where there's multiple exchanges where they're all centralized still, but there's different trades that are happening. So how do you determine the price across many exchanges? So let's say Coinbase, Gemini, Kraken.
Yeah. So this is where the concept of a volume weighted average price comes in. And the idea, it's just a simple arithmetic weighted average based on the volume amounts. So for instance, if 3,000 of an asset have been traded in one place for a certain price, and 30 of the same asset in another place, then the price that we display on Messari will be the average between those two weighted by the volume. So it'll be much, much closer to the higher volume market price. This happens, in real time with 35 exchanges. It's conceptually the same. It helps that the vast majority of trades in every exchange are still a pretty similar price most of the time. You can imagine that there would be immediate arbitrage opportunities if the same asset traded for vastly different prices in two places. So like in the very early days of crypto, this was probably more possible than it is today, because now there's so many people looking at it that you have like arbitrage bots that will spot these opportunities in seconds and collapse them into nothing. So every so often we'll get a trade where an asset trades for an unexpected amount because someone pulled off arbitrage. But usually that's rare now. So in practice, it ends up not influencing the price probably too much to do this. But the reality of it is, like, if we're talking about, for instance, the price of Ethereum or another very large asset, the price that we display on Messari is going to be very, very close to the price on centralized exchanges, just because the volumes there are so high. And represent the vast majority of our throughput.
Yeah, so taking a shift here to the decentralized world, 2 years ago, we saw the rise of DeFi summer, which was a huge boom with Uniswap being the front runner there. But the approach of trading on Uniswap is vastly different than trading on a centralized exchange. Can you talk a little bit about what is the innovation there with Uniswap?
Yeah, the innovation is the supply curve between two assets, right? So to participate in Uniswap, you provide two assets. For instance, like ETH and USDC being the most common two right now, Ethereum and US dollar coin. You provide these two assets to a pool, and then people can freely trade between those two assets by, doing a subsequent transaction on the blockchain. And it sort of takes care of itself in some sense, because, you supply X ETH and Y USDC, and those two amounts are just available. So if someone wants to purchase Ethereum from you and they add USDC to the pool that you've already put into the protocol and take the Ethereum out. And as people do that, the marginal price of whichever asset there's less of in the pool will increase. So the idea is that, if someone wants to drain you of an asset, they're going to pay a huge premium for that. So in general, both assets would be available in the pool. That was the first way that Uniswap works. Now, of course, with Uniswap v3, it's much more complex than that. But in the early days, it was sort of I can't remember the exact formula. I think it was just an inverse proportion between the two assets determined the price of the assets. So you had it's very much not an order book, but you still had a process by which some people with liquidity would provide that to the system, and then others would be able to swap assets using that liquidity. And then a fee would be extracted on top of that trade for the provider of the liquidity. So from our point of view, we can still look at the swaps that occur and figure out how to derive a price from those. But you can go deeper, as many do, and as we will do very soon, to provide like a very large amount of data about like what is the current state of the pool as well, like how much liquidity is in and how much of each asset and so on.
So what are some of the advantages of using a decentralized exchange over a centralized exchange?
That's a good question. Well, first of all, obviously, it's without oversight by a centralized institution. The second is that I think to contribute to a DEX is more of it's a liquidity position, like it's an investment into the expected fee revenue that you're going to get out of the pool, right? So it's sort of functionally extremely different. It's a way to gain interest on your assets, as opposed to a standard order book market, which, I mean, it can be a way to, I don't know. It's not functionally the same, right? Because like in an order book situation, you probably just intend to change the nature of your position. Whereas when you're investing into like a liquidity pool, you are sort of keeping the same position, functionally speaking, but gaining interest on top. So it's quite different. So it helps like those with liquidity provided in an efficient manner to a market versus the, order book version, which is more about like, I guess, modifying your position. That would be my take. I'm probably missing something there though, because I have never been in the position to really deeply use Coinbase, for instance, or any other centralized market. And it's been much more about like passive fee revenue from DEXs for me.
Yeah, absolutely. One thing that you did mention here is, as a liquidity provider, you actually gain fees for participating in DEXs, whereas in centralized exchanges, Coinbase or Gemini takes basically the entire share of the pie.
Yeah, I guess the way to summarize that would be, in some sense, if you are providing liquidity to a DEX, then you own part of that market now, and you would get some of the fee revenue. Whereas if you're using a centralized provider, then it's sort of just they that own the market, and you are helping it, provide revenue for them. So.
Yeah, you touched on arbitrage a little bit early on, and that is sort of the game theoretical approach of keeping the prices relatively the same across centralized exchanges. So if, let's say, on Binance, things are trading at, let's say, like 2,600 for ETH, whereas Coinbase 2,500, then you have $100 of arbitrage here.
Yeah.
We also, with the rise of DEXs, we also have seen this game theory play out in the decentralized world. Do you want to touch a note on that for our audience?
Yeah, there are so many things that you can do, but the simple version is just, let's take Uniswap v2 as another example. You have two liquidity pools which share one asset in common, for instance, right? Let's say that asset is Ethereum. Again, it's worth 2,600 in one place, 2,500 in another place. Because of the innovations of DeFi, you can, in the span of a single transaction, extract value from just that very price difference, right? Like you can have a bot that purchases ETH at the cheaper price and immediately sells it at the higher price in a different pool, and you can do that instantaneously. These days, that was done, way back, a couple of years ago, and it's done today at a much larger scale. But now we have further innovations like flash loans, which I believe was also a Uniswap innovation. Is that right? But I might be wrong about that. But the idea is that you can actually take a loan from the protocol, broadly speaking, or from a pool. As long as you repay it plus interest in the same transaction, you can use that for whatever you want. So now you don't even, to run an arbitrage bot, you don't even need to actually have the liquidity that you want to take advantage of. You just have to have, there has to be an opportunity for this arbitrage to take place, which would be worth more to you than the percent fee that you're taking for the flash loan. So in practice, people have bots that if you spot a price difference between two assets, they'll immediately take out a flash loan, execute the trades necessary to take advantage of the arbitrage, and return the flash loan. So yeah, it's incredibly optimized at this point for major assets on major DEXs.
Yeah, absolutely. It's a cutthroat world out there.
Yeah. And now you have gas fee competitions too, where people will put in their transactions at like very, very high value. So most of the value of this arbitrage tends to sort of trickle. It tends to be less valuable to the people running the bots over time, as the network can take advantage of the fact that people want to get their transactions in, because there's 45 bots that all see this one opportunity. So you have to bid. Essentially, you're bidding for your block to be mined first, right, or for your transaction to be mined in the next block. So you end up with like less benefit for you over time.
Cool. Now setting the stage here, we have centralized exchanges with order books and trades that happen when a taker takes an order from a maker. And we also have decentralized exchanges where a swap happens when someone decides to trade and takes liquidity out of the liquidity pool. Piecing it together. So for a user in crypto, a consumer, the end goal here is being able to analyze this space and being able to see, hey, what's trading at what asset is priced correctly, maybe what is the movement across time. So first thing first, how do we get all of the data together in one place in real time? What are the challenges associated with it?
Totally. Yeah. So as I mentioned, a great deal of the centralized data comes from one provider who already standardizes the trade format for us. So that's fortunate because that takes away 20 or so integrations. But in general, we have this pool of trade ingester processes. They're just tiny little processes that all observe a specific market or a specific set of markets, send trades as they occur to a centralized service or to a single individual monolithic service that we have running all the time, our market data service, our pipeline. And we have this long and complex process of turning those raw trades into actionable data. And the core of it is, some trades are simple if they're traded in the form of US dollars, which has become the standard currency for the most part. Standard, you get it, base asset to price things in. It's easy if you're observing coin-based trades that are already priced in the form of dollars. But it's much harder to figure out how to handle assets or trades between assets where neither of them necessarily have a particularly consistent dollar price. So a great deal of engineering time and effort has gone into this. Is both back in the day, like when Messari was much younger, and today we've recently rewritten it, how to handle those trades and price them correctly. So I could definitely dive into that to whatever extent we want to in this conversation.
Cool. Just to give folks a sense, what is the scale of data that we're ingesting right now?
Totally. Yeah, right now we're up to, it's pretty inconsistent because it really just depends on how volatile the market is. In volatile times, trade volume is way higher. So for example, back last year, we saw peaks in the 400,000 trades per minute range. These days, things have quieted down. Prices have been more consistent for a few months. And we're seeing somewhere like between 60 and 120,000 trades a minute at this point.
Cool. So shifting gears for the builders that might be out there, I think a lot of folks building in this space fundamentally need market data. Market data, I think we can talk a lot about the hotness that is happening out there. Things like new DAOs that are forming, new assets, new projects that are coming up, new protocols. But at the end of the day, if there is no market data, if there is no price, there's no volume, there's no market cap, then it's very hard to contextualize what this protocol is. So for the builders out there who might be thinking of building on top of market data, what are some of the technologies that you recommend using, both from maybe a storage perspective as well as a general aggregation architecture perspective?
Yeah. So, I mean, if you wanted to build your own pipeline for price data, then you would need some sort of provider for the vast majority of the data, right? So otherwise, you're just talking about building bespoke integrations for 30 things, and that's time prohibitive. So we start, as I mentioned, with Kaiko, which of course an individual would not want to immediately think about because it's an enterprise product. But we have, for instance, a number of really good community projects that can help out in this goal. One of them is CCXT. CCXT is a library. I think it's in 3 languages that handles the process of polling centralized exchanges for you and standardizing the response. There's also a pro version, CCXT Pro, where it'll handle WebSocket streams for you as well. And that's as real time as you can get. And that is excellent as a starting point. But in practice, due to rate limits, you're not going to be able to easily run CCXT to observe all of Binance, for instance. And if you did, like, the throughput would be very high, that it would overwhelm most small processes, right, that you would run on like a virtual server. So CCXT would be the proper starting point, I think, to just think about, like, okay, if I have this stream of trades, what can I do with it, right? And of course, Messari itself we have time series data going back a very, very long time, back to 2009. So that's cool too. But in terms of like observing it in real time, CCXT is a start. As far as where to put it, like how to store it, I mean, really, the world is your oyster. There's definitely time series databases that are designed for it. We use Timescale DB here at Messari. Timescale is an excellent engine on top of Postgres that eases the process of dealing with time series data at a very large scale. You can have like arbitrarily large SQL tables that are relatively performant, as opposed to ordinary SQL tables that top out when you're talking about like hundreds of thousands or millions of rows. So that's a start.
Nice. What about on the decentralized side? If I wanted to pull in data from various DEXs, maybe across protocols, what would you use?
Yeah, it's a current problem, right? Messari is pretty dedicated to the graph at this point. The graph being a GraphQL. In the future, as it gets more adoption, it will be an incentivized tokenized network that incentivizes people to provide useful GraphQL APIs for blockchain data. Today, it's mostly centralized, but it's still excellent. We use the graph for the vast majority of our 20-something integrations that we have decentralized world right now. And I had something else about that, but I have lost it. Yeah.
Part of the reason that we're using the graph is that it is community driven, and that it is public data, public indices that anyone can access. But the downside of the graph as well is that it is public and anyone can contribute and anyone can be building a subgraph. So what we've seen is there's a wide quality difference between a subgraph that is built by, say, the Uniswap team that powers their analytics, or a subgraph that is built by a weekend tinkerer that maybe adds an integration out there, but it's not ready for production usage.
Yeah, and there's another thing. So the graph is, just to summarize it a little bit better, it is a protocol by which you can create and supply GraphQL APIs, right, for arbitrary smart contracts. Like, you can write a subgraph which translates the events that are actually occurring on the blockchain into actionable, useful, organized data. And first of all, it's very focused on Ethereum at the moment, the developer community. So that's one thing. It's harder to branch out to other chains, especially the higher performance ones. One problem that we have at Messari, for example, is that Binance Smart Chain is, as far as I understand, impossible to index fast enough to query using something like the graph. People are trying. It is not currently working very well. So it's very difficult to grab real-time insights from like the very highest performance chains, or the ones that emphasize throughput as much as possible, like they do. But a lot more success in Ethereum world. We have a small and growing number of subgraphs that we use in production today.
We're also in the process of building subgraphs. So want to touch a bit on that. Why are we building subgraphs?
Yeah. As you said, the quality of subgraphs is quite variable. There are some that are maintained by projects that power info sites, and there are others that are created by tinkerers. And it really just depends on, a protocol is unlikely to have a particularly good subgraph that's truly reliable unless it is necessary for that project's website or useful to someone, If in a particularly, again, it's such an engineering effort to create a good subgraph that you need to be incentivized to do it in some way most of the time. So we have that problem. We want to increase the number of high quality subgraphs that exist, and we want to use them ourselves, right? We want to present the data in a relatively standardized format that people can get used to, both for our own purposes and for the purposes of the community.
Yeah, that dovetails well into the data integrity problem. that it exists both in the decentralized world, it exists in the centralized world, and it exists especially in times of high volatility where certain assets just on our platform can just shoot up, even though their importance is very, very low.
Yeah.
Can you touch on some of the data integrity problems that happen in this space?
Yeah, a number. The one that comes to mind first is one that keen observers to our site will have noticed from time to time that you mentioned, which is like a very small asset that nobody really knows about will shoot up in the ranks. Usually that's because, well, it's because of a couple of things. The first is that there is this arbitrage situation that we've described previously in this conversation, which prevents prices for major assets from fluctuating too much, right? But for tiny assets that no one's heard of, it's very possible that someone who's playing around will execute a trade on a decentralized exchange involving that token. I'm talking mostly about ERC20s here, but it could be anything. It's possible that someone executes a trade just an incredibly unfavorable price, right? So for instance, nothing is stopping you from paying exorbitantly for a token that no one cares about. And sometimes people actually do that, and we will ingest that trade, and it will cause, genuinely someone did pay this crazy US dollar price for this asset, right? So it'll cause that price on our site to reflect very high. That's one problem. Then of course, there's tons of minor things that just happen from time to time. For instance, well, I won't name it, but there was a large centralized exchange a few months ago that very briefly fed garbage data through their WebSocket just for asset prices in the trillions of dollars. And, because there's this fundamental problem where you sort of have to trust the data that's coming in, like you can't have any rule that says Bitcoin will never trade for $100,000. Like that's a bad way to build the system. So you can't really check for it, like in absolute terms. But sometimes bad data comes in that says Bitcoin's trading for, $100,000 or more. And you have to deal with that somehow. So that's sort of the environment in which we live. If we want to aggregate everything and if we want to display real-time data as quickly as we can, we have to make judgments about that data's integrity that are very difficult to get right 100% of the time.
So we have a pipeline that is highly tuned at this point to ingest large trades of data. As you mentioned, thousands of trades per second. Right. Once it goes into our system, we also go through a cleansing phase before outputting to our normalization phase. Let's dive into a little bit of both.
Yes.
What type of cleansing do we do? Or what type of cleansing do you have to do as an industry such that the data is actually valuable to the end user?
Totally. Yeah. There's a couple things to preface this conversation with to frame it, I think. The first is that this is not a problem that occurs in centralized finance pretty much at all. We have some employees at Messari who formerly have worked for large, regular finance institutions, and this is sort of a new area to explore. So I think people are experimenting with how to do this correctly. At the end of the day, it is a statistical problem. You have a large amount of data, the integrity of which is uncertain, and the only judgments that you have about how valid this data is are the prior data from an instant ago or yesterday or whatever. So in the old days, meaning prior to last year when our pipeline was rewritten, the way that we did this was with a median price check. And I'm talking about just one layer of validation. Of course, there are more, and we can get into those if time permits. But what we would do is we would say, like, okay, we've seen these trades. We've recomputed this asset's price in light of these trades. Is this asset price sufficiently close to the price 1 minute ago or 1 hour ago, such that we don't, there's no huge discontinuity between the prices we've ingested for this asset recently. In practice, this didn't work very well because there's no value for a median or for I'm sorry, I didn't get into it quite right. So we check, the most recent price. We take the median of recent prices, and then we multiply that by, I believe, 5 is what we were doing. And we were saying, like, okay, if this asset trades for less than 5 times what it traded for an hour ago, then we're fine. In practice, that didn't work very well because there's no multiple to select that really solves the problem. First of all, like if you set the multiple too low, like if it was 1.2 times, then in extremely volatile markets, like assets genuinely sometimes do 10x in a very short period of time, right? if they take off somewhere, they get listed on Coinbase or whatever. Sometimes that can happen. So you can't have a heuristic that says just ignore this asset because the price seems discontinuous. So that's why we have a very high multiple, which is 5x. And that worked okay, but there were a lot of situations where an asset that hadn't been traded in 24 hours would suddenly have, a trade that made no sense. And that's a problem we're still exploring. But today we have a little bit more of a statistically appropriate way of dealing with short-term fluctuations. And what we do there is it's a standard deviation strategy. So we still observe all the prices that occur in the recent past, like in the last hour in particular. And we observe how different those prices are from the mean in their markets. So for instance, the actual average price of this asset, let's say, is $2,000. I'm using Ethereum-ish prices for most of this conversation. Of course, most assets trade for less. But yeah, you have a true volume-weighted average price in this moment. What is the average price deviation that markets are observing? And how different is this price from that deviation? So, for instance, you would say like, okay, Ethereum trading for $2,400 somewhere is probably not right if it's trading for $2,000 everywhere else, even if the multiple is within 5 times of the expected price. So that's just one example.
Yeah. So so we've zoomed super deep in. Taking a step back here, in terms of volume, what are we seeing in terms of centralized exchanges versus decentralized exchange? Just in terms of rough scale, are people using a lot more centralized exchanges, or are people using gradually more decentralized exchanges?
I'm not sure if I could speak to the slope of the line, but it's definitely dominated by centralized exchanges, and slowly decentralized is getting more important. But it seems pretty slow, and it still seems like most trades are going to occur on centralized exchanges for the time being. Another thing that's tough about that is like trades are of arbitrary size, right? Like on a centralized exchange, if you're using Coinbase Pro, for instance, you can select exactly what you're putting on the order book. But if you're a casual user, you're not going to do that. And in practice, like Coinbase is going to do that for you in tiny chunks, right? So like if you're trying to buy, $3,000 of crypto, and you might have like many tiny orders. And so we're going to ingest like 10 trades. But for a DEX, like someone might execute one trade that's huge. So in terms of like the volume of trades that occur, that's what's really more important. And we still see centralized dominance there too. So.
Yeah, I think at the end of the day, probably speed kills here. Moving through centralized exchanges, trading through centralized exchanges, just so much faster than decentralized exchanges.
Yeah.
In terms of bottleneck, do you think we are bottlenecking on the speed of Ethereum here? Just to give folks a sense of why DEXs are slower versus centralized exchanges.
Yeah, that is part of it. There's this, because of gas fees, people are unwilling to make small trades for the most part on Ethereum, like the base layer. L2s will change that. High performance chains aren't that way, but we can't really index them fast enough to display them on the site yet. So I think it's inevitable that we're going to see that. But again, like that doesn't say anything about, like there are whales out there who pretty much, exclusively use DEXs, right? And they'll execute gigantic trades all the time. And well, all the time, however often they do. And it's really hard to say like what it's going to take to shift volume over to DEXs. Like large institutions have no incentive to do that because they want their fees. So it's not like, one of the large centralized exchanges will likely move over to a decentralized platform to execute trades on. It's possible, but it doesn't really make business sense for them. So it's really just about the user experience of whatever chain you're talking about at that point. And that, who's to say what is going to happen there as far as what gets widespread adoption next,
Right.
Yeah. So for the time being, we're going to remain in a world where if you want to see crypto prices, you do need to pay attention to the centralized players. I guess that's not 100% accurate for some assets, because a coin that comes to mind that's existed for a really long time, like Tornado Cash, for instance, as far as I know, Tornado doesn't trade in any centralized places, or at least any major ones that we observe. That may not be true anymore. Someone can correct me. But I remember looking into it at the time and not finding one. And at the time I was confused about, this was back when I was newer to the space, I was confused about the idea that like this coin could be popularly traded even if it's not on somewhere that I can turn it into dollars, right? But that happens too. And then you have a truly apples to oranges comparison. Like if this asset were placed on a centralized exchange, would it trade more there? Yes, probably, just by virtue of the way the casual users work. But
yeah, you bring up a very interesting use case with Tornado Cash that centralized exchanges fundamentally cannot provide, which is the concept of privacy. With centralized exchanges, if you onboard and offboard from centralized exchanges, you go through KYC, AML,
yes,
and your whole identity needs to be revealed. And you also have to be in certain jurisdictions in order to use, for example, Binance versus Coinbase. Whereas in a decentralized world, and especially with the Tornado Cash example, you can operate in a private way, and you don't necessarily need to reveal your transactions.
Right.
I think Tornado Cash is sort of an off tangent too from the Monero Zcash incantation of the coins, and Zcash is a Ethereum equivalent, although not quite there yet.
Right.
Do you want to touch on a little bit of how Tornado Cash functions?
Yeah, sure. It's a really cool project. The idea is that there are smart contracts where you can deposit standardized amounts of crypto, right? So for Ethereum, for instance, I think it's 0.1, 1, 10, and 100. There might be more now. I haven't gone on in a while. But the idea is you deposit this amount and you receive an identifiable code to redeem it later, right? That you must return back to the contract in order to extract your amount. So if you deposit 10 ETH and wait 6 months and then withdraw 10 ETH, there's nothing on the blockchain that indicates the link between those two transactions, right? You're given a key that only you know. And so like you can use it to redeem your funds, but if you redeem it on a different address, then there's no telling which 10 ETH you're withdrawing, right? Based on everyone else. The idea is like there's this anonymity set of amounts that are all the same, and you just can't easily link them together. So it's a clever information hack to use a blockchain not designed fundamentally for privacy, beyond addresses being anonymous, hopefully for some people, in a very, very anonymous way. It's a very cool project.
Mm-hmm. Yep. And then in the future, I believe they're experimenting with some of the ZK tech as well.
Mm-hmm. Yes. Yeah. Zero knowledge proofs are they're going to have far reaching implications far beyond crypto as well. But that's not really my area, but it is going to be very exciting. Yeah. I don't know. It is true what you say about you can operate on DEXs in an anonymous manner. And the truth is, to do that, you have to jump through some hoops, right? Like there's tax jurisdictions to worry about. You're talking about tax fraud if you're advocating for people to not report ultimately their income when they redeem it back to dollars, or for Americans whenever we flip between crypto assets in the first place, even if we're not going back to dollars. But you can anonymize a great deal of your behavior. Like if you really wanted to, you would put money on the blockchain, or rather you'd put it in a centralized exchange and then send it to a wallet. So then it's truly on the blockchain instead of, managed by you, as opposed to managed by the centralized exchange that you're using. And then you would put it in Tornado and leave it there for 4 months and then withdraw it again. And then you've achieved, a lack of linkage, hopefully, between like what you were doing in a centralized world and what you were doing over here. But sadly and happily, right, you have to eventually that has to get back to you in order to be useful to you as a person who lives in the world who can't pay for things at a store with ETH, right? So that would be the true innovation whenever we get there, would be like being able to pay for real world goods, just using a wallet address that somehow we can keep private and during that transaction. That's going to take some time.
Yep, absolutely. Well, with that note, I'll turn it back to Ryan for any questions that you might have.
Awesome. So right now, it doesn't look like we have any questions in the chat itself. But one thing that I'd say, Adam, good opportunity to shill folks that might be watching the technical presentations, especially on the engineering site, if they're looking for jobs. What's exciting about the problems in like market data resolution in particular, and like, what would be the type of person that would respond really well to joining you and your team in helping scale this up? Because we're not short on challenges, but I know we definitely want to have more folks here so that we can continue to add not only feeds but also potential products we can build on top of market data.
I think it's a fascinating problem space. It centers all around like very high performance code at a very low level. So it's a different type of problem solving than you'll often face, like in software engineering. Like a lot of the time, it's about getting the business logic right, representing things correctly to be extensible later. All that still applies, but in terms of dealing with the amount of trade data that we ingest now and we expect to ingest in the future, we're talking about, okay, how many bytes is this array that represents this trade? Like, how can we make it smaller? In order to build an extensible system, we have to think about those things immediately. And we've recently, through the rewrite of our pricing engine that's been mentioned in this conversation, we have created an environment where we're ready to do that. We're about to build a huge number of integrations. So there's the slice of the work that's thinking about the high performance aspect, and that's mostly what I'm focused on. And then there's this portion of the work that's all about researching protocols more, building subgraphs, helping the ingestion occur closer to the chain. Both are essential pieces for what we're trying to do. And I think at this point, the way I would conceive of our mission is get all the trades all the time, everywhere. And that is a challenge. But yeah, it's a type of work that I feel privileged to have found an opportunity to do, because I love the performance-based code problems. And if anyone else likes those, they should definitely consider helping us out with it and coming here to do so. It's really fun. Yeah, that's my shill. Hopefully that suffices. I could go on for a very long time about that, but yeah, as Ryan said,
that's perfect. That's perfect, and that's just as good a place as any to end. So we'll get you off the hot seat, since there don't appear to be any questions in the chat. Means that you guys were comprehensive and left no stone unturned. So. Appreciate Diran, you and Adam taking the time walking through this. Continues to add to our pretty exciting library of technical content. So be sure to check out engineering.messari.io, where all of these sessions live. If you want to go check out some of the previous conversations we had on on-chain data ingestion, on DAOs and NFTs infrastructure, and front-end development and crypto for some of the tools that we have on the Messari site. Until next time, thank you very much for joining us. Thank you, Adam, and we will see you online.